There are symbols that speak to all of humanity, a simple heart, a peace sign, and then there's an equation. Just 5 little characters. E equals mc². You've seen it everywhere. On t-shirts, in movies, scrawled on chalkboards by cartoon geniuses. It's the most famous equation in the world. But it's more than just a symbol of smarts. It's a cosmic secret, whispered to us by the universe itself. This isn't just math, it's the story of creation and destruction, of the stars above our heads. The power locked deep inside the heart of every atom. It's a key that unlocked a new reality, forever changing how we see everything. These 5 symbols hold a truth so profound, it's almost poetic. They tell us that the stuff we're made of, the matter all around us, is really just a form of frozen energy. This is more than a science lesson. It's the story of E equals mc². The year is 1905. The place is Bern, Switzerland. Our hero isn't a famous professor at a grand university. He's a young man named Albert Einstein, working a humble job as a clerk in the Swiss patent office. By day, he examines other people's inventions, schematics for new kinds of typewriters, electrical gizmos. But by night, and in every spare moment, his mind was on fire. He was wrestling with the biggest questions imaginable. What is time? What is light? What is the very fabric of space? He was running thought experiments, imagining himself riding on a beam of light, chasing it through the cosmos. This single year, 1905, would later be called his Annus Mirabilis, his miracle year. In just a few months, this unknown patent clerk published 4 groundbreaking papers. Photoelectric effect later won him the Nobel Prize. Proof of atoms confirmed microscopic reality. Special theory of relativity rewrote space and time. It was an explosion of genius unmatched since Isaac Newton. Tucked away as a short addendum to his paper on relativity was a 5th little paper. It was only 3 pages long. Its title was a question. Does the inertia of a body depend upon its energy content? It didn't make a big splash at first, a theoretical afterthought. In it, he proposed something radical. If an object gives off energy, like a flash of light, it must also lose a tiny bit of mass. The two were linked, the first glimmer of the world's most famous equation. So, what does E equals mc² actually mean? Let's break it down letter by letter. It's simpler than you think. There are no scary mathematical operations here, just multiplication. The equation is a sentence, a cosmic rulebook written in the language of physics. The first letter, E, stands for energy. Energy is the capacity to do work. It's the go and the do of the universe. Heat from a fire, light from a lamp, motion of a thrown ball. Energy makes things happen, from the tiny twitch of a muscle to the explosion of a distant star. The next letter is M. This stands for mass. For most of us, mass is just weight, the stuff you can touch, the heft of a bowling ball, the delicate lightness of a feather. Mass is a measure of inertia, resistance to being moved. The more mass, the harder to push. M represents all the physical stuff in the universe. You, me, the earth, the stars, the substance of reality. And finally, c². The letter C is the cosmic speed limit, the speed of light in a vacuum. About 300,000 kilometers per second, 186,000 miles per second. Fast enough to circle Earth more than 7 times in a second. But in Einstein's equation, it's not just C, it's ce². You take that enormous number and multiply it by itself, the magic multiplier that makes the equation so incredibly powerful. So let's put it all together. E equals sign mc² tells us the energy locked inside an object equals its mass times c². Mass and energy are interchangeable. You can convert one into the other. Even a tiny amount of mass can convert into a tremendous amount of energy. This value is the conversion factor between mass and energy, the universe's exchange rate, not dollars to euros, a penny into a mountain of gold. C2 is that lopsided rate. Your little mass is worth an enormous amount of energy. That's why nuclear reactions are so powerful. The squared term amplifies mass to unbelievable effect. The squaring of C isn't arbitrary. It follows from the geometric logic of relativity, which blends space and time into a 4-dimensional fabric, space-time. Motion and energy in that framework lead naturally to the squared relationship. It's woven into the structure of reality. The universe isn't saying mass and energy are linked. It's shouting that the smallest speck contains vast potential, magnified by the fastest thing there is, squared. Let's bring this cosmic idea down to Earth. Forget about stars, galaxies for a moment. Let's think about something you can hold in your hand. A simple 1-gram paperclip. It's a tiny, insignificant piece of metal. It has a mass of 0.001 kilograms. According to our old way of thinking, it's just a paperclip. It holds papers together. But according to Einstein, that little paperclip is a treasure chest of energy, a sleeping giant. Let's use his equation to wake it up. E equals mc². The massum is 0.001 kilograms. C squared is 90 quadrillion. Now multiply them together. E equals sine 0.001 x 90 quadrillion. The result? 90 trillion joules of energy. That's a number so big it needs a comparison. That energy is roughly equivalent to the bomb dropped on Hiroshima, all from one paperclip. Let that sink in. Complete conversion of 1 gram into energy would be catastrophic. Enough to power a major city for a day, more than thousands of tons of TNT. All that potential locked in a humble office supply. Don't worry, your desk isn't about to explode. It's incredibly difficult to unlock. Most chemical reactions like burning wood or exploding dynamite release only a tiny fraction of stored mass energy. They rearrange atoms, they don't convert them. To tap E equals sine mc², you must go deeper, into the atom's heart, converting a piece of the atom's mass directly into energy. For decades, E equals mc² was a beautiful but abstract idea, a prediction on a piece of paper. But humanity, for better or worse, is very good at turning theories into reality. Scientists began to wonder, could we actually do it? Could we convert mass into energy here on Earth? The answer came from studying the atom. The nucleus, the tiny dense core, is held together by an immense force. Break that nucleus apart. Fuse smaller nuclei together. In the process, a tiny bit of mass vanishes. Not gone, transformed. Converted into a massive burst of energy, exactly as Einstein predicted. This is the principle behind nuclear power. In a nuclear reactor, heavy atoms like uranium are split in a controlled process called fission. The pieces weigh slightly less than the original. The missing mass becomes tremendous heat, boiling water into steam to turn turbines and generate electricity for our homes and cities. But this same principle has a darker side. If the fission process is not controlled, if it runs wild in a chain reaction, you don't get a power plant, you get a bomb. The atomic bombs of the Manhattan Project were the first terrifying, real-world demonstration of E equals mc², a small amount of plutonium or uranium converted into an explosive force of unimaginable horror, forever linking Einstein's name with the dawn of the nuclear age, a connection that brought him great sorrow. So E equals mc² is a double-edged sword. It gave us a clean, powerful source of energy without carbon, and it gave us the most destructive weapons ever created, capable of ending civilization in a blink. The equation itself is neither good nor evil, it's just a fact of the universe, a fundamental truth about matter and energy. How we choose to use it, to build or to destroy, is up to us. Look up. On a clear day, you can see the greatest proof of E equals mc² in the entire solar system. It's our sun. For centuries, we wondered how it worked. If it were made of coal or wood, it would have burned out long ago. The answer lies in Einstein's equation. The sun is not burning. It is a gigantic nuclear fusion reactor, converting matter into energy on a colossal scale. Deep inside the core, temperatures exceed 15 million degrees Celsius. Hydrogen, the simplest atoms, are squeezed together, overcoming repulsion to fuse into helium. If you weigh the 4 hydrogens and then the helium they make, helium weighs slightly less. About 0.7% of the original mass disappears, converted into pure energy, gamma rays, neutrinos, and light. Every second, about 600 million tons of hydrogen become 596 million tons of helium. About 4 million tons of mass transformed into radiant energy. Sunlight travels 93 million miles, 8 minutes to reach us. It warms our planet, drives our weather, powers photosynthesis. The light on your face was, moments ago, a tiny piece of the sun's mass. We are living in the glow of E equals mc². Einstein's equation didn't just explain the macrocosm of the stars, it also became an essential tool for exploring the microcosm of the subatomic world. A new generation built particle accelerators, giant circular tunnels, sometimes miles around, where tiny particles like protons are whipped to nearly the speed of light and smashed together. How does E equals mc² play a role? It works in reverse. We've seen mass to energy, like in the sun or a bomb. Accelerators do the opposite. They turn energy into mass. Enormous kinetic energy momentarily becomes new, exotic particles, which then decay. By studying these particle showers, physicists uncover the rules of the universe, discover new forces, and identify the elementary particles that make up everything we see. The discovery of the Higgs boson was a perfect example. Predicted but too massive to see directly, scientists pumped enough energy into a collision to equal the mass of the Higgs, allowing it to materialize for an instant. E equals mc² told them how much energy they needed. Converting energy into matter is a cornerstone of modern physics. The universe isn't a fixed set of particles. It's a shimmering sea of potential where energy and matter can be exchanged. What we call particles are, in a sense, concentrated packets of energy. E equals mc² is not just for bombs or power plants. It guides cosmologists and particle physicists trying to answer the biggest question of all. What is the universe made of? So what is the ultimate meaning of this simple, powerful equation? It's a message of unity. It erases the line we once drew between the physical world of matter and the dynamic world of energy. It tells us they are one and the same. Matter is not solid. Matter is not static. Matter is not dead. It is condensed, structured energy. And energy is not some ethereal force. It is liberated matter, free to move and interact. The universe is a single, unified entity, constantly transforming from one state to another. The rock, the light, the star, you, it's all part of the same cosmic dance. This idea connects us directly to the cosmos. The carbon in our cells, the calcium in our bones, the iron in our blood were not created on Earth. They were forged in ancient stars, fused and released according to E equals mc², scattered by supernovae, then gathered into new star systems, including our own. We are, in the most literal sense, stardust. The atoms that make you once lived in a star. The energy powering your thoughts came from food, from plants, from animals, from the sun, and the sun's energy comes from the conversion of its own mass. You are linked, unbroken, to our star and the explosions that came before it. So the next time you look at the stars, remember, they are giant factories turning matter into light. And when you look in the mirror, remember, you are a collection of ancient starlight. E equals mc² is more than physics. It is our connection to the universe. We are not just in the universe is in us.